Okay, guys, this is the practice final for College Algebra Math 150 for the fall term. We are going to start with number 1. And on number 1, you notice it says determine whether the relation is a function. Remember, for a relation to be a function, each x can have only one y. And when I look at these ordered pairs, I notice that we have two x's that are the same, but they have two different y values. So since that x has two y values, this is not a function. So that's number 1. Number 2 wants you to find the domain of the rational function. So domain, remember there's 3 things we can't do in math. 3 things you can't do in math. Number 1, you cannot divide by 0. You cannot take the square root of a negative number. If you do, it has to become imaginary. And then 3, you cannot take the log of 0 or the log of a negative number. That's undefined. Well, what's going on here? Okay, so in our problem in number 2, we don't have a log, we don't have a square root, but we do have divide. So we can't divide by 0. So we need x plus 2 to not be 0. So if you subtract 2 from both sides, that means that x cannot be negative 2, because when x is negative 2, negative 2 plus 2 is 0, you have to divide by 0. So now it wants domain as an interval. So if our domain was all real numbers, that would be from negative infinity to infinity. But we're not doing that. So our domain is going to be from negative infinity up to negative 2, but not touching negative 2. So parentheses on negative 2, or union symbol negative 2, comma, to infinity. And what happens on this problem for the domain there, if you were to graph that, there is a vertical asymptote, watch your mouth, at negative 2, and that's why the graph is undefined there. Okay, question 3. It says let f equal this set of ordered pairs. So this is not a continuous function. This is not a line, a curve. You don't connect the dots. You just have 3 points that make up this function. It wants you to find the f of 5, so that's like f of x. So basically we're letting x be 5. So in your ordered pairs, when x is 5, y is negative 1. Okay, question number 4 says solve the following equation using the quadratic formula. I notice that we have a binomial times a binomial, so I'm going to distribute or FOIL like that. And I'm going to multiply that out, so I get x times x is x squared. Negative 10x is on the outers. Negative 2x is on the inners. And last times last is going to be positive 20. And that equals negative 16. So it says the quadratic formula, but you actually can solve it any way you want to. I'm going to factor. I notice these are like terms, so I'm going to have x squared minus 22x. And then I'm going to add 16 to both sides, add 16. Because I have a quadratic, I want to set it equal to 0. So I get plus 36, 20 plus 16 equals 0. And this may or may not factor. I don't know if you noticed that mistake I made right there. Pretty big mistake. Negative 10 minus 2 is not negative 22. I believe that's negative 12x. That makes more sense. And then we want to multiply to get a positive 36 and combine like terms to get a negative 12. So multiply to get a positive, so either they're both positive or both negative. The middle sign's negative, so they're both negative. And my two numbers are going to be 6 and 6. Negative 6 times negative 6 is positive 36. Negative 6 minus 6 is negative 12x. But we only have one answer, because when you bring it out of the parentheses, remember you change signs. So you're not going to say the answer is 6 comma 6. The answer is just 6. All right. Number 5 wants you to evaluate the piecewise function at the given value of the independent variable. So we have 2 lines that we're piecing together. One is 4x plus 3, the other is x plus 5. And this over here is the domain. So our x is negative 1. So which domain does that fall into? That falls into less than 0. So we're going to plug our negative 1 into the first equation. So 4 times whatever x is plus 3. We know x is negative 1. So 4 times negative 1 is negative 4 plus 3. we get negative 1. So when x is negative 1, y is negative 1. Okay, question says graph the function, and it's a piecewise function. You're going to graph x plus 4 for when x is greater than 1, and you're going to graph x minus 4 when x is less than or equal to 1. So what I know about these two equations is it's already in y equals mx plus b form. They both have a slope of 1, because that's the number in front of x. And the first one has a y-intercept of 4. The second one has a y-intercept of negative 4. And this is the one that says an equal to on it. So the one that has a y-intercept of negative 4, okay, is going to be filled in, the filled in dot. The one that has a slope of positive 1 and a y-intercept of positive 4 is going to have an open circle. So I notice this has an open circle up here, right there, and down there. This one has a closed circle on the x plus 4 line. This one has a closed circle on the x plus 4. Now this one has an open, so we got it down between these two graphs. Now you're supposed to use this line when x is less than 1. So if this is x equals 1, I'm using the y-intercept of negative 4 when x is less than 1, less than or equal to 1. So that's why B is the right graph. This one is using the y equals x minus 4 line when x is greater than or equal to 1. So that's why that's not the answer. So B is the answer. Okay, question 7. I want you to graph, and it's multiple choice, so it's f of x equals x squared plus 6. So that's going to be a parabola that's been shifted up 6 units. So the answer is going to be D. Remember, you have a graphing calculator, so you could graph that on your y equals screen in Zoom Standard. Question 8 gives you a f of x and a g of x, and it wants you to find f divided by g of 4. There's a couple of ways you could do this. I'm going to find the f of 4. So everywhere there's x, I'm putting parentheses. So x squared minus 5, and instead of x, I'm plugging in 4. That's going to be 16 minus 5, which is 11. And then I'm going to find the g of 4 using the g equation. So I have 20 minus whatever x is, and x is 4. And so that gives me 16. And it wants us to do f divided by g. So that's going to be 11 over 16. Okay, question 9 says let f of x equal 9x minus 9 and h of x equal x plus 9 over 9. Evaluate the f of h of 9. So that open circle does not mean times. It means it's a composition. F of h of 9. That's the way I like to rewrite it. So you have to work your way from the inside out. First thing I got to find out is what is the h of 9 equal to. So I'm going to go over here to the side and use the h equation. The h of 9. So in our h equation, it's x plus 9 divided by 9, and we're letting x be 9. So 9 plus 9 is 18. 18 over 9 is going to be 2. So that is what the h of 9 is. The h of 9 is 2. So I'm really finding the f of 2, okay, because I'm plugging that in right there. And so now I'm going to use the f equation, and instead of f of 2, I don't know why that won't write. There we go. So f of x is 9 times x, 9 times whatever x is, minus 9. And we're plugging in x equals 2. So that's going to be 18. 18 minus 9 is going to give us a 9. All right, next question wants to know, are the two functions inverses of one another? And the reason why they have the red line on here, the functions they want you to look at are the blue ones, g and f. The red line is the y equals x line. And if two functions are inverses, they would be symmetrical across the y equals x line. These are not a mirror image from one side to the other. So for example, if I had this over here and then this over here, a mirror image, then they would be inverses. These are not, so the answer is no. Okay, question 11 wants you to find a formula for the inverse of f. When you hear the word inverse, I just think opposites. And so on inverses, what you're going to do is you're going to switch x and y and solve for y. You're going to switch x and y and solve for y. So this used to be y, f of x is y. So where that is, I'm just going to put x on that side. And then where the x was on the right, I'm going to put y. And now I'm going to solve for y. So how do I get y by itself? I'm going to get rid of the cube root by cubing both sides. So x cubed is x cubed. On the right, the cube root and the cubes cancel, leaving you with y minus 4. And then you're going to add 4 to both sides to get x cubed plus 4 equals y. And that's not any y, that is the inverse. And in our problem, they had originally labeled that as f, so that's f to the negative 1 means inverse, and it's going to be x cubed plus 4. Okay, number 12. The distance that a person can see to the horizon from a point above the Earth's surface varies directly. Okay, so distance varies directly as what? As the square root of the height of the point. So distance varies directly, so some constant k times varies directly as what? The square root of the height of that point. If a person is 144 meters high, can see 18 kilometers, okay, so this is the height, and this is the distance. How far can a person see the horizon from a point 16 meters high? So there's a couple ways you can do this problem. I'm just going to use this formula. So 144 meters high is going to be my height. So I'm going to put that right there. And at that height, the person can see 18 kilometers. So I'm going to solve for k, the constant of variation here. So the square root of 144 is 12. So this is really 18 equals 12k. Divide both sides by 12. And we get 3/2 equals k. That's my constant of variation. So now I can come back over here and say, all right, so the distance equals 3/2 times the square root of the height. And it says, how far can a person see, so that's the distance they can see, when the height is 1,600 meters. So we're going to put 1,600 in there. And I believe the square root of 1,600 is 40. Let me double check it. It is. So we have 3/2 times 40. And half of 40 is 20. 20 times 3 is going to be 60. So the person can see 60 kilometers. Okay, question 13 says, find the vertex of the graph of the quadratic function. So this quadratic equation is given to you in standard form. So I'm going to use the formula to find the x value of the vertex. You need this formula. X equals negative b over 2 times a. All right, that's part of the quadratic formula if you remember that. So over here in our problem, a is 2, b is negative 8, and c is 10. We don't really need c for this to find the x value of the vertex. So I want the negative of whatever b is over 2 times a. b is negative 8, and a is 2. So we get positive 8 over 4, and we get x equals 2. So that's the value of x in the vertex. Whoops. So we know x is 2. Well, how do I find y if I know x? We plug it back into the equation. So we're going to find the f of 2. So when x is 2, what is y? So 2 times whatever x is squared minus 8 times whatever x is plus 10. And you can type all that in the calculator. let's see, 2 squared is 4, 4 times 2 is 8, minus 16 plus 10, that's negative 8 plus 10, that's going to be a positive 2. So our y value was also 2. You could also verify this. If I was taking my final, I probably would go ahead and graph it, like do it this way, but then graph it on my calculator on the y equals screen and see if 2, 2 is the vertex of that graph. Okay, question 14. Find the vertex of the graph of the quadratic function. This one's actually easier than the last one because it's given it to us in vertex form. Vertex form is y equals a parentheses x minus h quantity squared plus k. And whoever's in here with x comes out and it becomes positive h, and whatever's at the end is what is at the end. So hk is going to be your vertex. So that's why it's called vertex form, because you can see the vertex. So with x is minus 4, when you bring it out of the parentheses it changes to positive 4. And then the y value is the number on the end, positive 6. Okay, question 15 says use the leading coefficient test to determine the end behavior of the graph of the given polynomial function. So my leader, first of all, you want to make sure it's in standard form. My highest exponent is my leader. My leading coefficient is positive. So my graph is going to finish positive. And because my degree is odd, odd means opposite, it's going to start the opposite. It's going to start the opposite of positive, which would be negative. So my graph is doing something like this over here, and it's doing this over here. Finish, you have to finish first. You look at your leader, we follow the leader. Our leader's positive, we're going to finish positive. Since our degree is odd, odd means opposite, it's going to start the opposite of how it finished. So the graph is going to rise to the left. Nope. It's going to fall to the left and rise to the right. You also can graph this on your graphing calculator and just read the graph if you don't know the rules for coefficients and degrees. I think I have a separate lesson on my YouTube channel on that if you want to go back and look at that. Okay, question 16 wants you to give the equation of any vertical asymptotes for the graph. The first thing I noticed is we have division, and when you have divide by 0, it can either be a vertical asymptote or a hole in the graph. If nothing cancels with the numerator, then it's going to be a vertical asymptote. It stays there, it's a pain in the asymptote. So our denominator is 0 when x minus 1 is 0. So if you add both sides, when x is 1, that's a restriction on the domain. So actually your domain is all reals but 1. But this is one to know where a vertical asymptote is. So that's where the vertical asymptote is at x equals 1. And you have to write it in as an equation. Okay, you could also graph this on the calculator and sort of verify your answer. Okay, so there's a couple of ways we could do this problem. To solve for a variable that's in an exponent, you can use logarithms. So you can just take the log of the left and the log of the right. And we have 1 over 27 here, and we have 3 to the x. And when you take the log of a number, and this is the common log because I didn't put a base on it, so it's base 10. It's the one that's on the faceplate of your calculator. The rules of logs are that if you take the log of something that has an exponent, the exponent can become the coefficient. That's called the power property. So this is really, oops, wrote that wrong. So this is really x times the log of 3. And that equals the log of 1 over 27. And so to get x by itself, you're going to divide by log of 3, divide by log of 3. And so you can use your calculator. On the home screen, you're going to type in log of 1 over 27 divided by log of 3. Make sure you close the parentheses on the log of 1 over 27 or type it in as a fraction. And I believe you're going to get negative 3 for this. Yep. Now, that makes sense if you think about it, because look, if I go back to my original problem, 3 to the negative third power, because we're saying x is negative 3, that does equal 1 over 3 to the third, which is 1 over 27. All right. Number 18, a deposit of $5,000 earns 3% annual interest. Find the amount in the account at the end of 10 years. First of all, it's annual interest. 10 years, and find the amount of interest earned during the 10 years if the interest is compounded quarterly. So they want you to choose which formula to use. This is the compound interest formula. This is compounded continuously. Compounded continuously. Lovely handwriting. I call that the PERT formula. We are not, nowhere in our problem did it say compounded continuously. So we're not using that one. We're using the compound interest formula. So P is the principal or what you put into the account. So that's going to be $5,000. R is our rate, but our rate has to be written as a decimal. So we're not going to use 3 in our problem. We're going to use 0.03. Annual means it's compounded once a year. So that's it's 3% annual interest. It's compounded quarterly, which is going to be 4 times a year. That is our N. Our N is 4. Okay? So we know P. P is how much we're putting into the account, $5,000. We know our rate is 0.03. N is quarterly, so it's 4 times per year. And it wants the amount after 10 years, so T is 10. So we're going to plug that into our formula. So our amount that we have, okay, is going to be 5,000, 1 plus R 0.03 point, all right, over N is 4, raised to the NT power, so 4 times 10. So you're going to type that in the calculator exactly like you see it, okay? Exactly like you see it. Let's see if I can do that. So we're going to go second quit, 5,000, parentheses, 1 plus a fraction, so alpha y equals. We got 0.03 over 4, close parentheses, to the 4 times 10 power, which I know is 40, but I'm just going to leave it like that. And so we get, where did it go? 6,741, 6741. We got to round to 2 decimal places. So 2 decimal places is going to be 0.74. 6741.74. Wait, did I say that right? Yeah, 0.74. Now, that's the amount of money you have after 10 years. How much interest did you earn? So the $6,741.74 is the amount in the account. That's A. How much interest you're going to take the $6,741 and subtract off what you invested. So you're going to subtract off $5,000. That's going to leave you with $1,741. $1,741 and 74 cents. So that's the interest earned. Okay, number 19. The number of grams of a certain radioactive substance present at time t is given by the formula A equals blah, where t is the number of years. Find the number of grams that are present at time at t equals 800. So this is a fairly easy question. A equals 500 times E. E is a number, 2.71, blah, 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 crap, to the negative 0.004 times t power. And t is 800. So you're going to type this in the calculator just like you see it to get to the E button. All right, and it says we're going to round to the nearest hundredth. So let's see. So I got 500. Second ln gives me e to the negative 0.004 times 800, just like you see it. And so we get 20 point, what did it say to round to? Round to nearest hundredth. So hundredth, tenths, hundredths, that's 2 decimal places. So we have 20.38. 20.38. That's the amount. And that's declining. So that's exponential decay. Okay, number 20. Suppose that g of x equals log base 3 of 2x minus 1 minus 2. What is the g of 14? It's a fairly easy question. Everywhere there's x, I'm going to put 14. So I have log base 3 of 2 times x, but we have x to be 14, minus 1 minus 2. All right, so that's 28. Actually, you can just type all that in the calculator if you would like. I'm going to do it without a calculator. We have log base 3, that's 28 minus 1, that's 27. Minus 2, log base 3 of 27 is going to be 3 minus 2. The answer should be 1. All right. If you were going to use the calculator to do log base 3, you hit alpha zoom. Just kidding, alpha window. I was right the first time. Number 5 is log base. So we have log base 3 of 2 times 14 minus 1, and then out at the end we're going to have our minus 2. So you can just type it all in just like you see it and you should get 1. And that is the answer. Okay, 21 wants us to use the calculator and the change of base formula. We don't need change of base formula because our calculator will type this in just like we see it. So I'm going to go to alpha window and number 5, and my base is 8.4. Oops. And 2.3 is in the parentheses. And we get 0.39136. It wants you to round to 4 decimal places. So if you're rounded to 4 decimal places, the 3 is where we're rounded to, so you look at the number to the right, and it's 5 or bigger, so we're going to round up. So it's going to be 0.3914. 0.3914. Let me double check that. 0.3914. That's right. Okay. Question 22 says solve. And it's a log base 5 of 5x minus 7 equals 1. So when you have one logarithm, you want to rewrite the log as an exponential. So you take the base is 5, you're going to raise it to the opposite power. So 5 to the first power equals what was inside of the log. That's how you rewrite the log as an exponential. So the base on the log is the base on this exponent right here. So 5 to the first power equals what was in the log. So now I'm just going to solve for x. I'm going to add 7 to both sides and divide both sides by 5. So my answer is 12/5. And that's that. Okay, 23 is a system of equations. And I notice that they're both in standard form. So what I want to do is I want to add vertically and make either x or y disappear. And I notice this is a positive 6y and this is a negative 3y. If I could make this negative 6y appear, then my y's would cancel. So I'm going to multiply the entire first equation by 2. So 2 times 6 is going to be 12x. 2 times negative 3 is negative 6y. 2 times 72 is 144. All right, my second equation I'm not going to do anything to. I'm just going to rewrite it underneath this one. Now when I add vertically, my negative 6y and positive 6y cancel. I get 17x equals 136. And then I'm going to divide both sides by 17. So 136 divided by 17 is 8. So now that I know 8 is x, how do I find my y? You can use either one of your first equations. I'm going to use the second equation because everything's positive in there. We make less mistakes when we use positive numbers, it seems. So 5 times whatever x is plus 6 times y is going to equal negative 8. And we know that x is 8. So now I'm going to simplify and solve for y. So this is 40 plus 6y equals negative 8. I'm going to subtract 40 from both sides. Negative 8 minus 40 is negative 48, and I'm going to divide both sides by 6. So x is 8, and then y is negative 8. And that's the point where the two lines intersect, and that would be an independent system because it has one solution. Okay, number 24 says solve the system algebraically. I notice I have my first equation is a parabola, my second is a line. The reason why I know it's a parabola is because it's x squared is degree 1 or 2, so it's a parabola or quadratic, and the bottom is x to the first, so it's degree 1, it's linear. So I'm going to take what y equals in the first equation and plug it in right there for y in the second. So in the second equation I have 5x minus whatever y is equals 6, and y we know is just x squared. So I have a quadratic equation I need to solve. So I need to set it equal to 0 and factor. So since this is negative x squared, I want to move that over here. So, and I'm going to move the 5x over there as well. So on the left, I'm going to be left with 0. And so negative x squared, when it goes to the right, it's like adding x squared. So positive x squared minus 5x plus 6. And we want to multiply to get a positive. So either they're both positive or they're both negative. The middle sign's negative, so they're both negative. And add to get 5. So 3 and 2. Negative 3 times negative 2 is 6. Negative 3 minus 2 is negative 5x. When you bring them out of parentheses, they change signs. So we're finding two different x values that make the equations true. So how do you find y? Well, I'm going to go back to my y equals equation. Y equals whatever x is squared. So if x is 3, y is going to be 3 squared or 9. So that is a point on our graph, that is a point on the coordinate plane where the two curves intersect, 3, 9. And if x is 2, y is equal to whatever x is squared. So what's 2 squared? That's going to be 4. So my second point would be 2, 4. Okay, 25 says sketch the graph of the solution set to the system of inequalities. First thing I notice is both of my lines are in y equals mx plus b form, which is nice. So the slope on the first inequality is going to be a 1, or if you want to make it a fraction, 1 over 1. Remember, that's your rise over your run. The b is negative 5. And my second inequality slope is negative 1 over 1, and my b is negative 1. I did not copy this graph. One moment. Oh, well, I'm just going to do a rough sketch here. So we have two inequalities. 1, 2, 3, 1, 2. So my first inequality has a y-intercept of negative 5, so that's not going to work. Let's see, 4, 5. So we're going to go down here to negative 5 and put a dot. And then we're going to rise 1, run 1 for the first inequality. Up 1, over 1, up 1, over 1. And it is greater than, so it is going to be a dotted line. There's no equal to on it. That's why it's not solid. And greater than means I would shade above this line. All right. So now I'm going to plot my second inequality. The y-intercept was negative 1, and it had a slope of negative 1. So we're going to rise down 1 over 1. Rise of negative 1, run of 1. And it is also dotted because there's no equal to. And it says less than, so less than would be below that. So I got to be above the red line but less than the blue line, so my shading overlaps over here. Okay, 26, we have an x squared and a y squared, and we're adding them. So think about if you had just an x squared, that's a parabola, just a y squared, that's a parabola. If you add them together, you get an ellipse, or a special ellipse would be a circle. So I have an ellipse. The thing I notice is that the y has the biggest denominator. So the ellipse is going to be longer in the y direction. A is wider in the x direction, so that's not the answer. Also, D is wider in the x direction. So I got it down to a 50-50 shot. The center of my ellipse is going to be, the center of my ellipse is going to be at +1, +2. What's inside with x, when you bring it out, you change signs. What's inside the parentheses with y, when you bring it out, you change your signs. So that's the xy center. So 1, 2. And I don't know if you noticed, but it looks like these are by 2s. 2, 4, 6, 8, 10. So this center is like at 2, 1. But this center, 1, 2, that looks to be the center of the circle. Or sorry, of the ellipse. So the answer is B. Okay, 27 wants you to find the equation of a circle that has a center 2, 1. So the standard form of a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. So we know the center of the circle is at 2, 1. Now when I put that in the parentheses though, I have to change the signs. Anytime you take something out of the parentheses or put it back in the parentheses, they got to change signs. So since x, that's your x and y values, alphabetical order. So inside with x, I'm going to put -2, the opposite of the center, and with y, I'm going to put -1. Now I've got to find the radius. The radius, we don't know the radius. They told us that the center is 2, 1. So like right here, and they told you it goes to the point -4, -2. 1, 2, 3, 4, 1, 2. And so the radius would be the distance from here to there. Now, there's a couple ways you can do this. There's the distance formula. The distance formula is, it's where you subtract your x's and square that value, plus subtract your y's and square that, and then you add them together and take the square root. But I also want you to see where that formula comes from. If I were to make a right triangle, I could use the Pythagorean theorem, which is where the distance formula comes from. So from down here at -2 up here to +1, that is a distance of 3. And here we're at -4 on the x-axis. Here we're at 2, so that's 6. So I could, if I'm trying to find the radius here, a squared plus b squared equals c squared. So 3 squared plus 6 squared equals the radius squared. That's going to be 9 plus 36. And that's going to be 45. Now, that is the radius squared. I don't need to take the square root of that because in my equation, I don't want the radius, I want the radius squared. So it is 45. Now I just want to show you really quickly how I could have used this formula over here and not the Pythagorean theorem. So we'll call this x1, y1. This will be x2, y2. And so if I take the second x and subtract the first x, that's -4 minus 2. If I take the second y minus the first y, that's -2 minus 1. And look what you get. You get -6 squared plus -3 squared. And that's 36 plus 9. That's the square root of 45. That's the distance from the center to that outer point, which is actually the radius. But we didn't want the radius. That's the radius, but we wanted the radius squared. So if you square both sides, you get r squared equals 45. Okay, 28, they want you to graph the circle. This one's really nice because nothing is inside with x or y. Remember this standard form of a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared. So everything is squared even though it's a circle. So since nothing is being added or subtracted to y or x, your center is at 0, 0. And this is the radius squared. So if you take the square root of that, the radius would be 6. So they want you to graph this. So on your graphing utility tool on your Math Excel, you're going to select a circle. You're going to click the center at 0, 0, and then you want it to go out to 6. And then it'll draw the circle for you in there. Okay, 29 is probably the hardest problem on the test because you have to complete the square. So it says find the center and radius of the circle. So the first thing I'm going to do, I notice I have an x squared and an x, but only one y squared. So I have an x squared and a y squared, so a parabola and a parabola, and I'm adding them. So I got an ellipse, or I could have a circle, which it tells me I have a circle. So I'm going to group the x's, group the y's, move the number to the other side. That's supposed to be a 12. I'm going to leave a space right here for a reason, and then I'm going to say plus y squared equals 13. So y squared, I already know the center value for y. It's going to be 0 because nothing is being added or subtracted to y. But I've got to make this a perfect square. So I'm going to add half of b. So in that box, I'm going to take b divided by 2 quantity squared. That's what's going to go in my box. So half of 12 is going to be 6. And if I add 6 squared on the left side of the equation, I have to add 6 squared on the right side of the equation. So now I'm going to rewrite this trinomial as a binomial squared. And the binomial, what makes it a perfect square, is plus 6. Now, if you want to know, I sort of skip a step there. This is 13 plus 36. That's going to be, what, 49? I skip a step right there. In the middle here, I could have done this. I could have said, okay, that's x squared plus 12x plus 36. And I could have factored that. And 6 times 6 gives you 36. 6 plus 6 is 12. But then we rewrite it like this. So now this is in the standard form of a circle. So my x inside with x is plus 6. So when I bring it out, negative 6 is going to be the center, the x value for the center. Nothing was in here with y, so 0. And then this is r squared. So when you take the square root of that, that's going to be 7. Okay, I think this is the last question. Sketch the graph of the hyperbola. So a hyperbola, so when you have a parabola and you add it to another parabola, it can make an ellipse or a special ellipse, a circle. But when you have an x squared and a y squared and you subtract them, it makes a hyperbola. And what I notice here is we have subtract, and they already told you it's a hyperbola, and the y is the positive one. So whoever is the positive one, that's the direction the hyperbola is going to be graphed. So we're going to be graphing the hyperbola in the y direction. This is in the x direction. This is in the x direction. So I got a 50-50 shot. And the center, now be careful, the center with x is minus 2. So the center, the x value of the center is going to be positive 2 because you bring it out of the parentheses. And inside with y is positive 1 when you bring it out. I'm pretty sure this is a common mistake because they see this one first and this one second, but it's not in the right order. Okay, so that's a no-no if I could get it to right. So my center is at 2, 1. So right 2. And these are counting by 2s. I don't know if you know. So 2, 1 would be right there. And that looks like that's the center. You'll notice over here, this is negative 2. It looks like negative 2, negative 1 center. That's for the person that didn't flip the change their signs.